Excuse me. In independent measures ANOVA, we have different people taking part in different experimental conditions, but in repeated measures ANOVA, the same people participate in all conditions of an experiment and provide data at multiple time points. So, a repeated measures ANOVA is used when the same entities participate in all conditions of an experiment or provide data at multiple time points. When repeated measures is used, the assumption that scores in different conditions are independent, like an independent ANOVA, is violated because scores taken under different experimental conditions are likely to be related because they came from the same participants. Because of this, the conventional F-test will lack accuracy if we assume that the relationship between pairs of experimental conditions is similar, which is called sphericity. Sphericity refers to the equality of variances of the differences between treatment levels. Sphericity can be assessed using a test known as Mauchly's test, which tests the hypothesis that the variances of the differences between conditions are equal. If Mauchly's test statistic is significant at less than 0.05, we conclude that there are significant differences between the variances of differences and the condition of sphericity is not met. If it is significant, we must be wary of the resulting F ratios. However, like any significance test, it is dependent on sample size. In big samples, small deviations from sphericity can be significant, and in small samples, large violations can be non-significant. If the data does violate sphericity assumption, there are several corrections that can be applied to produce a valid F ratio. These corrections are called the Greenhouse-Geyser correction and the Heinfeld correction. The same types of variances are found in repeated measures ANOVA and independent ANOVA, but the only difference is whether the sum of squares come. In a repeated measures ANOVA, the model and residual sum of squares are both part of the within participant variance. The data for a repeated measures ANOVA should be in the long format. The data should include 3 or more time points or conditions in which the same group of participants were involved. My research topic examines if there is a change in reported work engagement scores depending upon the motivation technique used. The same group of 25 participants experienced 4 motivation techniques, which are TED Talk, Pamphlet, Camp, and Incentives, and after each experience they take a work engagement test with a reported score. So the participants are involved in the IV, which is the motivation technique, and the DV is the work engagement score. I use a repeated measures ANOVA because the same group of people were involved during each condition of the IV and all have reported scores after each condition. I began by installing the necessary packages to run repeated measures. The package Easy is used to run in ANOVA. The package ggplot2 is used to create graphs. The package MultComp is used for post-hoc test. The package NLME is used if you decide to use a multi-level model. The package PastX is used for descriptive statistics. The package Reshape2 is used for reshaping the data. And the package WRS is used for robust test. I now library them so that I will have them, which I've done previously, so I probably already have most of them already libraried. Then, once this is done, which might take a little while. Now I'm going to attach, but next I'm going to attach the data set. Now, the data was entered into Excel in the Y format, so I had to convert it into the long or Y format for R to be able to run the necessary test. I did this by using the melt function and specifying columns in the data that identify characteristics of the scores and columns that identify the scores themselves. By using these functions, I created a new data set called Work E, right here. The data frame contains 3 columns. The first identifies the participant, the second identifies the type of motivation method, and the third contains the scores on work engagement test. I next labeled the columns to be participant technique and score. Then I converted the technique variable to a factor with suitable levels of TED Talk, Pamphlet, Camp, and Incentives. To make it clear that there are 4 work engagement scores for each person, I've sorted the data by participant, which we do here. Next, we're going to get the descriptive statistics of the different groups to explore the effects of the technique or work engagement scores. And this is where we can see all of them. And On average, the work engagement score was highest after the incentives technique and lowest after the pamphlet technique. These mean values are useful in interpreting any significant effects that the main analysis reports. Using knowledge that I've learned in previous chapters, I set my contrast appropriately. I predicted that the incentives and camp techniques would yield the highest work engagement scores. My first contrast compares the incentives and camp techniques combined to the pamphlet and TED Talks camp techniques, which is what I'm doing here, fun versus boring. Then I set the contrast and then bound the variables together for the technique. The next one separates the incentive and camp technique, and then the third one separates the pamphlet and TED Talk technique, which is what I'm doing here. And then next is actually when I bind them. I bound the variables together for technique. I then checked to make sure I had the contrast set correctly, which is what I'm doing here, just to make sure everything's done right. When checking to make sure they are correctly set, you have to remember that positive numbers are compared with negative numbers, and a 0 means that the group is not involved at all. So this checks out correctly. Next, I conducted a ANOVA using a repeated measure design using the easy ANOVA function. The advantage of this method is that it produces an output that resembles what you'll see if you attempt a repeated measures ANOVA using a different package such as SPSS. It also computes sphericity estimates and corrections for sphericity. The assumption that the variances of the differences between levels are equal, or the assumption that the condition of sphericity exists, has been met, with W equals 0.97 and P equals 0.984, which we will see when we report the model. I haven't run it. Yes, now I'm going to report it, sorry. This is where we see those values. If this had not been met, we would have to use a correction factor that is applied to the degrees of freedom used to assess the observed F ratio. There's a sum of squares for the repeated measures effective technique, which tells us how much of the total variability can be explained by the experimental effect, and this value is 99.52. There's not a significant difference between the four motivation techniques and their effects on the work engagement scale scores. F equals 0.48. When reporting whether or not an effect was found, in order to make sure the F-test is accurate, you must look at the greenhouse geyser and hindfoot corrections, which in this case both report non-significant findings. Next, I looked at the planned contrast I created for the model earlier by creating a model called contrast model, which is what I'm doing here. I specified maximum likelihood as my method because I am doing repeated measures ANOVA. I also specified random effects, which is an effect that can vary across different entities. I specified it to show that when we look at the variable participant within the variable technique, then overall levels of the outcome work engagement scores vary. By including this term, I'm telling the model that the data with the same value of participant within different levels of score are dependent or from the same person. A summary of this created model gives a set of parameters that relate to the contrast I set earlier for the technique. I want to test whether a technique had an overall effect, so I need to create a new model that does not include the predictor to compare this model to. This model is called the baseline model, and instead of including technique as a predictor, I include only the intercept, which is denoted with a 1. By comparing the created contrast model to the baseline model, I am able to see whether adding the variable technique as a predictor significantly improves the model, or in other words, I can tell whether the model fits the data better if I don't include the predictor technique. Next, I'm going to run it and compare the two. The degrees of freedom change from 4 for the baseline model to 7 for the contrast model because technique has been coded with 3 contrasts, which means that the 3 parameters, because there's 1 for each contrast, have been added to the model. The reported AIC and BIC tell me about the fit of the model, and the smaller values mean a better fit. The fact that these values are larger in the contrast model than in the baseline model tell me that the fit has gotten worse with the addition of my predictor. If the model had been improved by the addition of the predictor, the likelihood ratio would tell whether the improvement in fit is significant. So, we are able to conclude that the technique is not a significant predictor of work engagement score. This type of motivation technique used did not have a significant effect on work engagement scores, and there's degrees of freedom of 3 and a p-value of 0.43. We then further explore the model with the summary function, which includes the perimeter estimates. First, when we compare the fun technique, which was the incentives and camp technique, to the boring technique, which included the pamphlet and TED Talk, work engagement scores were not significantly different. T equals 1.25 and P equals 0.214. The second contrast tells us that there was no significant difference in work engagement scores after using the incentive and camp technique, T equals 0.98, P equals 0.33. And then the third contrast tells us that there was no significant difference in work engagement scores after using pamphlet and TED Talk technique, because T equals 0.42 and P equals 0.676. Although I would typically not look at the post hoc test and only look at the contrast, for the purposes of this assignment, I ran the post hoc test using the pairwise function, and I found that there is no significant difference in work engagement scores after each motivation technique. Now, I'm able to find the effect size from the column labeled GES in the EASY and NOVA output, which we saw earlier. The value for the technique is 0.027. But as we've seen, it's typically more useful to have effect sizes measures for focused comparisons rather than the main and NOVA. So I calculated effect sizes for the contrast I set. To use the code rcontrast, which the book uses, I had to download and library 2 new packages, which is why they are this far down. And let's hope they work. They worked earlier, so they should. Now I should be able to run these. And this is my t value found earlier, and this is my degrees of freedom. And the results showed that the difference between the fun technique and the boring technique was a small effect of R equals 0.146. The incentive and camp technique, between the incentive and camp technique, had a small effect of R equals 0.115. And between the pamphlet and TED Talk technique had a very small effect of R equals 0.049. So, there we go.